Hello students, in today's video we will see next method of numerical integration, which is Simpson's 3/8 rule. So in the previous videos we have seen trapezoidal rule and Simpson's 1/3 rule. So here now we will see Simpson's 3/8 rule. So for Simpson's 3/8 rule, we need Newton's forward difference polynomial which passes through 4 points. See, in trapezoidal rule, we use Newton's forward difference polynomial which passes through 2 points. For Simpson's 1/3 rule, we use Newton's forward difference polynomial which passes through 3 points. And now for this Simpson's 3/8 rule, we are going to use Newton's forward difference polynomial which passes through 4 points. So suppose we have 4 points, x0, y0, x1, y1, x2, y2 and x3, y3. Our polynomial passes through these 4 points. Then we can find approximating polynomial by using Newton's forward difference method. So for that, first let us find Newton's forward difference table. So this is a Newton's forward difference table. Now here let k is equal to x minus x0 upon h. Then Newton's forward difference formula or polynomial is this: y0 plus k times del y0 plus k into bracket k minus 1 upon 2 factorial del square y0 plus k into bracket k minus 1 k minus 2 upon. So here it is not 2, it is 3 factorial. So 3 factorial into del cube y0. Alright. Now see, so this is the approximating polynomial. This polynomial will approximate given function f of x which passes through those 4 points. Okay, now let us integrate this. So integration from x0 to x3 f of x dx is integration from x0 to x0 plus 3h, because all the points are equidistant. In place of f of x, now we will use its approximating polynomial dx. So now here we will again use this substitution. K is equal to x minus x0 upon h. So x is equal to k into h upon x0, and therefore dx is h dk, and the limits will change. Now new limits for k will be 0 to 3. So this integration will become integration 0 to 3. Just open this bracketed terms, okay? We will get this term h dk. And after this integration, we will get this. Integration from x0 to x3 f of x dx is equal to 3h by 8 y3 plus 3y1 plus 3y2 plus y3. So we got this integration from by using Newton's forward difference polynomial. So we are approximating this function f of x by Newton's forward difference polynomial. So we get this value. So this is approximately equal to. Now using this, we will evaluate our original integral, this I, which is equal to integral from a to b f of x dx. Now look at here. So this is our graph of our function y is equal to f of x. We have to integrate it from x is equal to a to x is equal to b. That means you have to find this area below this curve above this x-axis between line x is equal to a to x is equal to b. So what we will do here, we will split this interval from a to b in n equal parts. Alright, so here the distance between x0 and x1 is h, x1 to x2 is h, like this all are equidistant points. So these are the corresponding values of y. Now if you remember, for trapezoidal rule, okay, before that, so let us call these areas are a0, a1, a2 up to an minus 1. So this total integration will be sum of all these areas. Now see, for trapezoidal rule, we used only a0. Okay, we found value of this a0, this area. So we considered single strips only. For Simpson's 1/3 rule, we combine first two strips. So a naught plus a1. So we combinedly found area of a naught and a1. Now in Simpson's 3a rule, because we need 4 points, so we are going to consider 3 strips, these vertical strips at a time. So we'll find area of this a0, a1 and a2. That means area bounded by our function f of x from x0 to x3, then from x3 to x6 likewise. So a0 plus a1 plus a3 is nothing but what? This integration from x0 to x3 f of x dx. And we know that now this is equal to 3h by 8. So it is approximately equal to 3h by 8 y0. That is our first ordinate, or this corresponding value of function corresponding to x0. So y0 plus 3y1 plus 3y2 plus y3. That is last ordinate. Okay. Now what about a3 plus a4 plus a5, next 3 strips? So it will be integral from x3 to x6 f of x dx. So this will be approximately equal to 3h by 8 y3 plus 3y4 plus 3y5 plus y6. Likewise, we can find areas of all these strips. So at the end, we have to find an minus 3 plus an minus 2 plus an minus 3. Last 3 strips. That is equal to integration from xn minus 3 to xn f of x dx, which is equal to this 3h by 8 yn minus 3 plus 3 times yn minus 2 plus 3 times yn minus 1 plus yn. Now we have to keep one thing in mind here. This has to be there is one more change here. This has to be a of n minus 1. Alright. Now one thing is here, that number of strips must be divisible by 3, because we are going to combine 3 at a time. Right. So number of strips must be equal to that number must be divisible by 3. That means the n should be multiple of 3. Okay. In trapezoidal rule, there is no condition on n. In Simpson's 1/3 rule, there is a condition on n, that n has to be even. Now here for Simpson's 3/8 rule, this n must be divisible by 3, because we are using 3 strips at a time. Okay, so after adding all this, we will get our integral, or this required area, which is equal to, so integration a to b f of x dx is approximately equal to 3h by 8. Now see, y0 will occur in only first set, yn will occur in only in the last set. So 3h by 8 y0 plus yn plus 3 times, so y1, look at here, this 3 times y1. Okay, then y2 will also repeat 3 times, so y1 plus y3. y4 is repeating 3 times, so y4. y5 will also repeat 3 times, but this end values will not repeat 3 times. Okay, y3 is here in the first set and it is in the second set also. Similarly, y6 will be here in the second set as well as it is in the third set also. These boundary values will repeat twice, so 2 times y3 plus y6 and so on up to yn minus 3. So what is happening here? First ordinate plus last ordinate plus 3 times remaining ordinates where the suffix is not divisible by 3 plus 2 times all the ordinates where suffix is divisible by 3 except y0 and yn. Okay, so this is how, by using approximating polynomial which passes through 4 points, we can find this integral, and this is a Simpson's 3/8 rule. Thank you.